This is part 2 of our sine and cosine ratios assignment. We just need to cover a few new things here. But just to review, the sine of an angle, so in this case sine of angle A is equal to the opposite over the hypotenuse. The cosine of angle A is equal to the adjacent over the hypotenuse. Again, we'll have to make sure those are memorized. Some folks were asking me, what is the sine and the cosine? They said, sure, it's defined by this, but what is the function, right? They're thinking algebraically. What is it actually doing to the numbers? And to answer their questions, it looks something like this. So the sine of x is equal to this infinite series summed together. So this infinite sum, this type of thing. You obviously don't have to solve for these until you get to calculus, but just realize that it's this big complicated function. And if you graph it, we can pull this up a little bit. It looks something like this, where the sine and cosine will both be less than 1. The ratio isn't going to be greater than 1. Basically, the hypotenuse is always going to be greater than either of the legs. And that ratio will go up, and then it'll go down, and then you'll go up, and then it'll go down, and then up and down, no matter what angle you're at here. I'll put a separate GeoGebra video that kind of helps explain that, but just know that it's a complicated function that kind of finds where on this curve you are. Okay, so the thing where you need to talk about today is the inverse. If you were familiar with and able to use the inverse of the tangent function, then this will be very straightforward and simple for you. It's because it's the exact same thing. However, it's just the inverse of the sine and the cosine. I'm not sure if the book has a good definition for it, but we'll use this page here. It says here that the sine of angle A, so the sine of this angle A, is equal to the opposite over hypotenuse, or 5 over 10, right? So the sine of angle A equals 1/2. But what is angle A, right? If we want to figure out what angle A is just based on these side length values, we need to figure out a way to isolate angle A from the sine of angle A. And so we can do that, actually. If we set up our equation, it looks something like this. It has sine of A, and remember, you can kind of think of it as having parentheses. Sine of angle A is equal to, I'll just put 1/2 here. 1/2. So one of the reasons why I put parentheses is folks are tempted to just divide both sides by sine. Sine isn't a thing. Sine is again a function. It's like dividing. I want to divide by square root because I'm multiplying by square root. You can't multiply. You can't divide by square root. You take the square root of something. Same deal here, right? It's the sine of angle A. It's not angle A times sine. So we can't just divide both sides by sine, but we do have an opposite function of the sine. Remember before how I asked you, like, what is x squared and then square rooted, right? These guys cancel out. You know, what is x times 2 over 2? Oh, like those guys cancel out, right? They're opposite functions. We have the opposite function of the sine. In this case, the opposite function of the sine is called the inverse sine. And we usually write it just like this with a little -1. I'm going to scoot this guy over so I have room. I forgot to do that earlier. It's a little hard to write out. When you multiply something by 2, you can usually squeeze it in the crack somewhere. The sines are really big. Sines and cosines and tangents are kind of big, so sometimes they're just hard to squeeze in there algebraically. But I can take the inverse sine of both sides. So I'm going to do inverse sine. That's the inverse sine. I'm going to put the parentheses here just to show you what I'm taking the inverse sine of. And I'll do the inverse sine here. So this is the inverse sine. Whatever I do on the left, I have to do on the right. Now it's pretty clear that the inverse sine of the sine of A, these two things cancel each other. and I'm left with just A. So angle A equals inverse sine of 1/2. And this I can actually calculate using Mr. Calculator. So you go over here, make sure you're in degrees, sometimes you have to hit the inverse button if it's not a separate button. And I just want the inverse sine of, I can do the function itself or put in 0.5, 1 divided by 2, right? It does everything in the parentheses first, and then does the inverse sine function. So the inverse sine of 1/2 is 30, which is good because that's what the book said. Nope, wrong one, sorry. Oh, I had it. There we go. Okay, and then same deal with cosine. There's an inverse cosine. The inverse cosine and the cosine cancel if you want to try and get something by itself. And you can plug that in the calculator. Here's an example. This says we just need to find the acute angle measures for this triangle here. So we can write out our ratio for angle R. Angle R, we can do sine or cosine or tangent. The reason why we want to do sine is because that gives us opposite over hypotenuse, and those are two known values. We could do opposite over adjacent and then do tangent. However, then we'd have to calculate for this side, which we could do. It is a right triangle. Pythagorean theorem exists, but that's a lot of extra work. Let's just keep it simple on ourselves and just use the sides that they give us. So to find angle R, we can use the sine of angle R is equal to 7 over 13, right? The sine of angle R equals 7 over 13. And once we get that, then we can just basically solve for R, right? Sorry, scroll down here a little bit. I can see most of it. There we go. So the sine of angle R equals 7 over 13. We need to, again, solve for that angle R. The book kind of skips the step of taking the inverse sine of both sides, but I can try and squeeze that in here. I can say that the sine of that thing equals the, squeeze it in real tight here, sine -1, that thing, right? These cancel, boop, and we're left with angle R equals the inverse sine of, that's right, 7 over 13. We can calculate this. Let's try our calculator. Inverse sine of 7 over 13. Let me remember that. Inverse sine 7 divided by 13 equals, I get 32 point something. They round up to whole values, which kind of annoys me. But sure, 32. Yeah, why not? So it says angle R is 33 degrees. Sorry. So if angle R is 33 degrees, now we need to find angle P. And for angle P, we know the adjacent and we know the hypotenuse. So we can do adjacent over the cosine is adjacent over hypotenuse. So the cosine of angle P is 7 over 13. The cosine of angle P is 7 over 13. Oops. Oh, sorry. Okay. 7 over 13. Take the inverse cosine of both sides. That gives us angle P equals the inverse cosine of 7 over 13. Inverse cosine 7 divided by 13. Again, if you're doing this on an iPhone calculator, you just hit 7 divided by 13. That spits out that value, or hit equals maybe. And then find the inverse cosine and just punch that button and it'll spit out. It should spit out. You should practice. Make sure you can do this on your own calculator because you do not want to go into a test not knowing how to work your calculator. In this case, it spits out 57 and change. So that gives us 57 or so. Notice here, we could have done this an easier way for part B, right? It asks here, sorry, how else we could have determined the measure of angle P. If we know what angle Q is, 90, and angle R, 33, we should be able to figure out angle P without doing any trig at all, right? We just know it's the triangle sum theorem, so we can just add these guys up. So just make it easy on yourself. Again, once you find two of the angles of a triangle, the third one doesn't require any trigonometry. Feel free to just subtract it from 90. And I'm really okay with that. Go ahead and try 13 and 14. Yeah, pause the video. Okay, so for 13, the measure of angle y, we have these known values. We're going to use cosine, the cosine because it's adjacent over hypotenuse. So the cosine of angle y equals 14 over 23. Or we can do the inverse cosine of 14 over 23 equals angle y, which is 53 degrees. Measure of angle z, again, make it easy on yourself. 90 minus 53 is much easier than doing inverse sines. But if you did the inverse sine, great, power to you. You should have still got 37 degrees. That's pretty much all I have. We'll be working on these problems in class and doing some other fun stuff. So thanks.